First, though, would you strap your granny to a spinning chair, then turn the lights off?
OK, Doreen, so I'm going to turn on the chair now, and there's going to be a loud clunking sound as I turn the brake off. Nothing to be alarmed about, OK?
OK.
You doing OK there, Doreen?
OK. But I'm not there.
OK, I'm going to slowly bring the chair to a halt, and then I'll turn it off. Is that OK?
I'll sleep well tonight after all the excitement.
The scientists behind this and other bizarre experiments, including pouring hot water into their ears and having the ground shifted under them whilst blindfolded, is
Dr. Raymond Reynolds. I'm from the University of Birmingham. I'm an expert in balance, so my main topic of research is the vestibular control of balance.
Vestibular balance control involves feedback to the brain from our eyes and ears on the position of our bodies. Dr. Reynolds wants to know which bits of it change as we age and how, to explain why it is that we're more likely to fall for no apparent reason as we get older.
Over the age of 65, 1 in 3 adults will have at least one fall per year, and that rises to about 50% over the age of 85. A certain proportion, roughly 20% of these falls, will lead to some kind of injury, and a certain proportion of those will be serious injuries, including hip fractures. And those are the kinds of injuries which really cause high mortality in older adults.
Surprisingly, the falls can happen to people with no obvious physical problems and often on perfectly flat surfaces with no trip hazards. The research into whether there are subtle, previously unknown age-related changes to the balance systems in the head started 2 years ago. Well, coming from a family of fallers myself, I asked Raymond to test me. Electrodes stuck behind my ears, a steadily increasing voltage applied. I started to feel tipsy. It's like the room is tilting slightly. My eyes, I noticed my eyes kind of move left and right to begin with. Oh, that's really spacey.
Yeah.
By stimulating my vestibular nerve directly, the nerve that carries positioning information from the inner ear, Raymond tricks my brain into thinking my body's spinning.
Firstly, it tells us that you're reasonably healthy. So it tells us you've got an intact vestibular nerve and that the signals are travelling to your brain correctly. Now, what I would like to do next is try and figure out which way you sway when we stimulate you. Okay? And that will tell us...
Sounds naughty, Doctor.
Behave. That will tell us whether your brain is interpreting the information correctly.
Right,
Okay? So if you feel stable enough,
yes.
I'm going to ask you to not hold on anymore.
Okay.
And just stand with your feet together. Just make sure you're aware of where that rail is.
Okay.
Obviously I'm here so I can grab you if there's a problem. Okay, try and relax. And coming now.
Oh, thank you for...
Okay.
Actually, I would have fallen then.
Yeah.
We were using a technique, it's formally called galvanic vestibular stimulation, where we directly stimulate the nerve leading from the inner ear, carrying the motion signals from the head. We use this to give a full sensation of movements. In a healthy person, this response in terms of the direction of sway should be directed approximately through the ears. In other words, if you're facing forwards, you should sway either left or right, depending upon the polarity of the electrical stimulus. Now, the nice thing about the response is that when you turn your head, the response should turn with your head. If you're facing forwards, you would sway left to right. But if you turn your head towards your right shoulder and we use the same stimulus, this should now evoke a sway response forwards and backwards. And so we can now use this technique to determine the accuracy with which the brain can interpret this movement information from the head to produce an appropriate compensatory sway response.
So this compensatory sway response, this is basically how you recover from a potential fall as you trip up or you miss the step, something like that. Are you leaning backwards or forwards in the right direction?
Exactly.
I enjoyed that, but some of Raymond's tests are quite nauseating. Why did the OAPs put themselves through it? Doreen, would it be extremely rude of me to ask how old you are?
78.
Why are you taking part in this?
Well, I've had a lot of operations done in the past and I thought, well, it helps science, doesn't it?
Do you worry about falling yourself?
No.
Fit as a fiddle?
Yeah, well, I hope so now.
At one point, 2 years ago, I fell twice in 2 days. Once over something in the garden that I tripped over, and once over a paving stone and went crashing down. But you could do that at any age on an uneven paving stone.
Keith, why are you doing this?
Well, I want to keep myself as active as I can for as long as I can.
And do you worry about falling?
A little bit, but I put that down to either eyes or ears.
What, you mean that sometimes you feel unsteady?
If you're walking behind me, you think, this chap's had a couple too many. You know what I mean? I sway across, but I don't fall down, and I have a touch wood. But I say, if I can pin down, is it possibly my eyes or ears?
So which one is it? Or is it both? Eyes and ears, or something to do with the brain? The Birmingham-based study is just now pulling together its results. So what are they finding?
We showed that as you get older, the functioning of the inner ear degrades. Now, we showed to some extent, but not completely, you can compensate for this degradation by increasing the brain's response to the remaining input. We didn't show any gross abnormalities with age in terms of the direction of your sway response. But the analysis is ongoing, and what we think we might be seeing is a slight increase in the variability of the response in terms of the sway direction evoked by the stimulus.
So you can't necessarily rely on the fact that as you trip over to the right, you'll instinctively save yourself by pulling yourself over to the left, that you may either go in the wrong direction or may not move sufficiently to compensate.
Possibly, yes. And so what we're ultimately interested in is determining whether such changes may be able to predict an individual's risk of falling, for example.
Dr. Raymond Reynolds from the University of Birmingham, ably assisted by plucky volunteers Keith, Gail and Doreen.